that's always a good place to be. It's pretty quiet, but that's okay by me because most Slack channels are too loud. We're doing pretty good speaker-wise, but still, if you're ever interested, just let me know. Or if your place of business is interested in hosting, it's a good way to kind of get your name out there and let people know who you are. So with that, I'm turning it back over to me as Joe the speaker. And we're going to talk about Jest, testing the hard-to-reach places. All right, so how many people test their code? How many people really love their tests and think they are awesome? There's no problems at all. Yeah, that's pretty much the way it is with me too. I think the thing is that we want to do testing, we want to do it, but it's. Oh, hey Kevin, did you hit record on that? If you haven't yet, okay, cool. Is that testing can be easy, but there's a lot of tricks that make it hard. So for the most part, you want to make sure that you have pure functions because they're really easy to test. And a pure function, as a kind of reminder, is you have the same inputs and you get the same outputs, and there's no side effects. So everything that goes in controls what comes out, and that's all you have to worry about. So same inputs and outputs means that it's going to produce the same results every time. You don't need to worry about any changing. And no side effects means that nothing happens external to the system. Wait for it. Boom. And side effects, of course, are big problems because they're harder to test. They're different every time. They create changes that you have to look out for. So before we get into dealing with side effects, let's talk about a good test. So here is a simple function. You pass in an object. It contains a balance and a name, and you make a new string that has that name and the balance. This is a pure function, really simple, super easy to test. The thing that's nice about these tests is it tells you something about the data structure, and it tells you about what you're going to get. So this test, for this type of test, really also serves as kind of documentation because you can see the structures that are going in and the structures that are coming out. So before we get into anything else, you should try as much as possible to do these tests. And really want to hammer this home because this whole talk is pretty much what you should do after you've exhausted all these opportunities. So try and refactor first, get those pure things out. You'll be so much happier you did. After that, you can start to be clever. All right, now that we are all going to follow best practices, we can talk about the hard things. The hard things in testing are things like side effects, so AJAX calls being probably the biggest one that we almost all have to deal with. I/O, such as date, time, and things like unique IDs. So these are all things that happen external to the system or change on every run of a function. And then the things that are kind of in the middle. Sometimes you can get around with them without any sort of mocks or anything like that, and sometimes you do need mocks. So those are things like black boxes. I don't know if anyone else has experienced this, but in my years as a front-end developer, I've had several times where someone says, will you just drop this on the page, the script tag, it'll just work? And it tends to blow up a bunch of stuff. So any type of buy now widget, maps, anything that's kind of like this third-party thing that they just want you to quote-unquote drop in, those are kind of black boxes. And then sometimes you want to just get around bloated libraries, maybe mostly just because they can make things take a long time to run. So only really, you may not have to deal with these with tests every time, but sometimes you do. All right, so the thing about the hard things is they're frustrating. And I think when most people say they hate tests, this is kind of what they mean. They mean everything's fine until you have to deal with something like what happens when a function needs a new date, and so every single day that you run it, the tests fail. Well, how do you deal with that? Or how about the function changes something in the database? It doesn't come up as often for us, but maybe if you're a Node developer or a full stack developer, changing things in the database, how do you deal with that? How do you deal with all those changes? All right, so we're just going to go through a bunch of different scenarios that I've come through, and I'm sure almost everyone in here has come through at least once. And we'll talk about how we can use Jest to kind of get around those. So the first one is accessing external data. All right, let's see how much I put in here. So we have a function, and it's going to call a service. It's going to get a series of albums, and it's going to reverse those and get the most recent two. So in other words, it's going to get the two most recent albums by some band. So you're going to have to use your imagination a little bit. Imagine the service is some sort of AJAX call. All right, so now we're going to get into the code. And it will look a little bit like this. How's this doing size-wise? We need to go up? I'm just going to go up anyway, because almost everyone wants it bigger. All right, so here's our service. Oh, just ignore that service. Here is our spec file. And so we want it to work that it's going to get the most recent albums, and the most recent albums will be this. Now this is one of those tests that works all good and well. It's already probably not ideal because it's hitting a live API call. But the real problem is what happens if the data changes. So imagine this is the data we're getting back, and all of a sudden something is added, and your tests break. So fortunately, this is the easiest one to get around. And what Jest does is it provides a way to add a mock of any given function. So what's happening in recent, you see, is that we're hitting this service. We're importing service from service, and then we're calling it. So to get around that, what we're going to do is we're going to create a mock. And the way you do that is you have this underscore underscore mocks, and this is just a directory. It has to be on the same level as what you want to fake. And in this case, we want to mock out the service. So inside that directory, you make the file the exact same name as the one you want to mock. So we want to mock this service. Just open that. So service is hitting an API and it's getting us the data. So what we need to do is we need to make something that resolves with a promise and returns that data. And that's real simple. So in here, we'll just have a series of albums. We're just going to capture this in time. And then all we're doing is exporting a function called service, and then we are resolving it, or returning a promise that resolves with that information. All right, so let me just turn off this one. And we'll look at the final version. So the only other change is you have to explicitly mock it, otherwise it will use the default one. And one of the only problems I have with Jest is that this isn't consistent. Sometimes you have to explicitly mock it, sometimes you don't. So I think for the most part, if you're doing a manual mock, so you're using that underscore underscore mock, and it's not a node module, you have to explicitly import it. So here we go. We explicitly import it, and now it's going to always get the same results. Even if our data changes, like let's say our service goes down and it returns an empty array, it's still going to return true, because again, we don't want our test to test whether the API point returns something. We want to test what happens with the data we get from the endpoint. You can have something else to test whether those API endpoints work or not. All right, so that's the first one. Probably the one that I reach for the most because it's out of the way. It doesn't muddy up your test file. Notice that the test file is pretty much identical, and it's kind of easy to read. So if you're skimming through the code, you see this really weird named file, you'll know exactly what's inside of it. All right, that was a pretty easy one. The next one's going to get a little harder. At this point, what we want to do is we want to create an employee. So this one comes up for me a lot if you have, say, a form where you can have multiple examples. Like let's say you're adding an employee, and you want to be able to have 4, 5, 6 employees. Well, sometimes you need like a unique ID so you can keep track of them, maybe so you can keep track in the array, or so you can submit them, or something like that. So a way I've gotten around that in the past is you use this nice function from Lodash called unique ID, and it's just, it does something, and it always has a unique ID every time it runs. So it will return 1, 2, 3. So for example, we're going to have a function that creates an employee. It'll take some details, and it will return a name and position, so we can have a standard kind of base object, and then any details we pass in, override it. The tricky part is this unique ID. So let's go down here. First, if anyone didn't know this, another nice thing about Jest is you can run regex on the test you want to run, so we can ignore all the other ones. So now we're running our employee. And let me just clean this up real fast. All right, so here's our employee. We're creating an employee. And then our spec file will look like this. Now I think the naive way to go about this is to hard code in these keys. So if you were to put in key 1 or key 2, these tests will work because it's changed that unique ID every time. But the problem is now they're really brittle. They're really tied to the order in which they ran. So if you want to do something like work on this test specifically and run it out of order, all of a sudden it will break. Not because the code is wrong, but because the order it runs in is wrong. The other big problem with this is it creates a lot of false negatives. So let's say we made a little change here, and we wanted to pull some details, some information out of the details, and we wanted to check to see if they have a first name. So if they have a first name, we'll use that. You know, sometimes we pass in first name. Now this actually is going to create a few problems. So let me just turn on this test suite. Look, it's the exact same as before. It's a little bit of a change, but everything's failing. Now here's the frustrating part, is that it looks like all these tests are failing, but you have to scroll way up to the top to see that the problem is that the bottom tests were failing. The problem is that the first test threw an error, which made it not run the unique ID function, and then everything else fails. So it makes it really hard to debug if you have something that's running in a weird order, and all these tests are failing, but they're actually not wrong. Nothing about the code has changed. So we're going to change this one up a little bit. Oops. Just get down here and delete it. All right. So now we're adding in a little bit of type check, or a little bit of, I don't know, not type checking, but we're adding in some defaults here. So the problem was that we weren't passing in details, and so we were trying to destructure something that wasn't an object. So now we're still not we're destructuring an object, so those paths all go away. But the problem's still going to remain. So let me just skip this one again, and we'll go into the final here. So the goal that we have here is we want to get to a point where we can have this key be 1 and have it return that way every time. Let's see if I have this in here. Okay, so what we're going to do here is we need to mock out this Lodash function. So let me just show you the import method, because that makes a difference. If you want to mock something that's at the root level, at the node module level, it's the same way as before. You create that mocks, but you have to make it at the root level. And in this case, since Lodash has that kind of nested structure, we have to make a directory called Lodash, and inside there we have our unique ID. So let me just change that, and you'll see something that's pretty neat. Okay, it wasn't as neat as I thought. Oh, I had an extra period in there. Let's see here. We'll say we want to move dot dot, 2 dot. There we go. All right, so notice everything passed. We're all passing here. But we don't have to explicitly import anything. It somehow is able to infer that we are mocking out a node module, which is nice, but could be a little bit of a problem. So this is nice 95% of the time, but the only time it creates an issue is if you want to do something that explicitly changes it. So let's say, for example, we wanted to test, I don't know, for some reason we wanted it to return a different ID. So what we'll do here is, probably the best way to go through. Let's go look at the mock. So what we're doing here is, from here, currently we're exporting 1, but we don't want to do that. Instead, what we want to do is we're going to create a new Jest function. This creates a mock, and then we're going to make a mock implementation. So what this means is whenever you call this function, return 1. But the nice thing is, since we're making a Jest function and not just hard coding what's inside of it, we can actually overwrite it. So we just find my finals test here. So now if we import, I'm just going to copy it. If we import our unique ID from Lodash, it's going to not import the actual function. What it's going to do is import that mock implementation. And then here, we can say, now in this one case, in this case only, we want you to return the number 2. So now we have our mock. It's auto-mocking all the time, but in the rare cases that we want to change it, we can actually import it. It'll import directly from that mock. We don't have to know the path. And then we can change it to return whatever we want. So in this case, 2. So now we're mocking out an external library, but we're also giving ourselves the flexibility. In case you're wondering, this also works on just mocks of regular services. So if we want to export that service as a mock implementation and then override it in specific cases, we can do that as well. Okay, so let's move on to the next one. Next one is impure data in a function. And so for this example, we're going to look at a date checker. So let me just do my cleanup again. Okay, why am I recording? I'm just going to start over. All right, so what we have here is a function. It's going to take in a date. It's going to use moment to parse that date, then it's going to find out if it's after 2 weeks. Maybe we're having some sort of scheduling application, and you want to make sure that whoever is running it, that it only works after 2 weeks, that they have to schedule 2 weeks out. So let me just start the test going here. Now this one is particularly frustrating because this is one that could work for, in this case, it could work for 2 weeks if you set it up, and then all of a sudden break on you. So if we were to set something up, if we set the date for the beginning of January, that's not 2 weeks out, it would yell at us. If we set it for August 15th, this will work for a little bit. In about 2 weeks, it would suddenly start working. So let's turn it off and let's look at what happens when it doesn't work. Okay, so let's say we wrote this test in January, it was working, and now all of a sudden it's breaking because it's expecting there not to be a message, but it thinks that this is 2 weeks out. All right, so the fix here is pretty similar. What we're going to do is this time, instead of mocking at the root level, which we could do, we're going to mock it only inside of the implementation. And the reason I would suggest this for something like Moment is Moment, if you haven't used it, is a very big library with 1,000 different functions. So if you mock it at the root level, you're almost certainly going to forget to mock something that's really important to someone else. So in this case, what we want to do is we want to mock just 2 functions. We're only using two mock functions. So I'm just going to pull this up so you can look at side by side. We are using the Moment constructor, we're using the isAfter method, and we're using the add method. So as far as the add method goes, we don't really care what it does. That's a moment magic. So we're essentially calling a no-op function. But we want to test that isAfter is false for most of the time. Notice here we have to import both moment and we have to mock it out. So there's a couple extra steps. And then we have to add this mock implementation, and you pass in a function that returns something. In this case, since moment returns an object that has certain methods, we're going to return that. And this one should work. So now we are saying that isAfter return false here. So it's going to say, no, this is not after 2 weeks. And for some reason, I wrote it twice. And the nice thing about mock implementing inside of the function is that we can also override it. So for example, we want to check what happens if it is at least 2 weeks past. So even though this date, 2018, January 14th, is clearly more than 2 weeks in the past, we want it to return true. So we'll add this mock implementation once, which means here and only here will it return true, and that it won't matter to other pieces of code. So it returns false here, and we get our message. We say just for this test, and this test only, return true. It returns true for this one. And then it returns false for the next ones, and it will keep returning false. So mock implementation once is this really nice way to override the behavior for only a single test while keeping kind of a default behavior in line. All right, and one last thing I want to show you. This one is kind of moment specific. And what we're going to do is we're going to we're going to set a certain date on moment. So what we're going to do here is we are setting moment to, let me just show you a break-in beforehand. So right now we're not mocking moment, and it's going to fail. But with moment and moment only, what you can do with moment is you can set a .now, which essentially fakes the date to be whatever day you want. So in this case, we're going to say, as far as moment's concerned for this test suite, it's always January 9th, 2019. So I bring this up, not a just thing, but this is really nice because I know most of us probably use moment, and it's a big pain. So where I work, we've actually changed it so that we set that up in the initial test setup file. So for all test suites, moment is January 1st, 2019. And then you don't even need to do it on a per test suite basis. I think if you were to, you could probably change it again here, but you have to change it back. So that's the only downside of doing it this way, is that it does kind of change moments internals. But it's really nice if you know, for the purpose of testing, that you always want it to be a certain date. You don't want to have to deal with it every single time. All right, I forgot to pause for questions. Any questions up to this point? Yep.
Yeah, so the reason you're overriding moment.now is because that's already used in the code, and so there's no way to write tests around it since they're going to change based on the current day.
Yeah. Yeah, so instead of having to mock it every time, which is what I tried before, this is nice because it essentially lets you use all the moments internals, but then make it so that it's predictable. Yeah. Cool. All right. Next problem is you want to test multiple types of impure data. We kind of looked at this. That's a mock implementation once. I believe there's also a mock once where you return an object instead of a function. I kind of prefer the function. I think it's a little easier to read. All right, so the next one is we want to test an impure library or a component. And so this is the example of the black box that I was talking about. And so what we have here is we got some black box, and all we know is that if there's an ID with map on the page, and you call this function, it will toss in some map stuff. Let's see if I can remember where it's at. Actually, I think I have a picture. Yes. So for example, it will toss in this map, pretend that's a map, and we didn't actually do anything of that, but it's some black box code that just throws a map in there for us. Now the problem with this code is that black boxes, of course, you don't have control over. So let me just show you an example. So here's our ride finder code. And if we just run it, so we're not doing anything here other than rendering it out, it's going to explode. And because this map container is using some document methods, and it's for some reason can't handle this inner HTML. So we can't change this third-party library. Obviously, that's not something we have the ability to do, nor would we want to for the sake of our tests. So the solution here is the exact same as before. What we're going to do is create a mock at the root level with the same name. I'm not going to try to be clever this time. And that will just overwrite it. So in this case, we don't really need to return anything. All we're going to do is return a just function, because remember, it's a black box. We don't really need to test what it's doing. We're going to trust that whoever implemented it did their own test. Instead, we just want it to run and not explode stuff. So right now, it's pretty much running a no-op function. But again, notice that we're passing in this just.function, or we're actually exporting this just function. The advantage here is that now we can actually make sure that it runs. So what's happening here is we're importing our component. We're importing this black box from some node module. We're running our wrapper. It's going to make a snapshot. But the key part is this render map is called. So now we're actually making sure that we don't really know what this function does, but we want to make sure that someone calls it. And that means that we still have a little bit of safety for our code. So if all of a sudden someone, well-meaning person in the future, runs this, takes out that render map part, then it will still run. Okay, that did not work as I expected. Let's see if we can figure out what happened. Oh, I turned off the skip. Gotta turn off the skip. There we go. So that's going to fail, but this time it's just telling it's a lot clearer what's happening. It's not just exploding because the internals aren't working. It's telling us that whoever called this function, or whoever ran this component, forgot to run it. So you may have noticed that this is using some enzyme stuff, and everyone knows that all the cool kids these days use React Test Library. And we We all want to be the cool kids. So here's an example, same thing. It's using the React DOM, so it's not using the testing library, but that's what it's using under the hood. And same exact problem. Let's just move this back to let's be able to do this. Interesting. For the 20 minutes that it takes for this to run. Just make sure I didn't actually leave it in there. Well, it's passing, proving me wrong. So much for that. You know, I made it this run the demo without it blowing up. That's pretty good. Better than average. But even if you're curious, you can still do all this fun stuff. And it'll still work. Aha. Interesting. Here we go. Here's the problem. Aha. We are not actually calling. Oh. Now I remember. There we go. We got there. So now it's blowing up on run. We'll move it back. And it'll pass on both of those cases. So it'll still work in testing library the same way. All right. Last one we're going to look at is not really about mocking something, but sometimes there's cases where you want to make sure that an external library is called even if you're not testing it directly. So in this case, what we're going to do, I'm just going to start over again. We have a validator function. So this is a pretty boring function, but let's say that we wanted to wrap this third-party library to check to see if something is an email. So we're calling this validator function. Now the problem is going to come up not here, because let's say we have some tests that are pretty good. Just enough to check to see that it works. The problem arises if some well-meaning person in the future doesn't really understand the code. And this one obviously is a little small, but imagine this is like 20, 30 lines, and they accidentally override the behavior and just do a simple test. So this is a problem because obviously, just because it has an @ doesn't mean that it's a valid email address. Now the problem here is that all of these tests will still pass. This one won't. So it could look like it's working, even if it's not. So you have two options here. One, you could try and make all these different examples of emails that should pass. Now the problem with that is you're stuck in the position that you're testing an external library, which you really shouldn't want to do. You shouldn't care how this external library works. You should care that it's doing its job. So instead what we want to do is we'll let the library do its job, but we're going to make sure that it's actually running, that we're not trying to get by to get around it. So what we're going to do is we're going to import our validator, and then we're going to create a spy where we're spying on that specific method, the is email. And then we'll have pretty much a simple test case, and we'll see if it works. And so that works. Now, if a well-meaning developer were to add in something like this to the code, then ideally that would fail. Yep, because now we're not calling the library. So spy is a good way if you want to go ahead and let that external library do its thing, call all of its methods. But you still want to make sure that we actually use it. You want to make sure that we're not getting around it. So this is a nice middle ground between not having to override a bunch of stuff while still having the confidence that we're using it and that someone's not going to accidentally break it. All right. So last thing is, why is this important? Well, the reason that that mocks and splies are important is you should use them as low as possible, but it's nice to get that 100% code coverage. So how many people have used Istanbul or some sort of code coverage tool? Okay, well you should use it, it's pretty nice. What Istanbul does is it runs through your code and it kind of gives you this nice little output of what kind of code is covered, what kind of code is not covered. So as you can see here, a lot of my code isn't covered, mostly because I have a bunch of files that I was skipping a bunch of things on. But what's nice is it also gives you these beautiful little HTML reports that shows you the amount of coverage you have. So albums is covered 100%, audio is covered 100%, and it breaks it down really nicely and shows you what's covered and what's not. So if you click into one file, for example, it will show you the statements that are covered, the branches that are covered, the functions that are covered, and the lines that are covered. So in this case, there are 2 functions. So if one of those is covered and one's not, you'll get 50%. But then within the function, you'll see which statements are covered. So any sort of variable setting, which includes times like this where you use short circuiting. It checks to make sure that you test both of those options. And it also checks any branches, so any conditionals or ternaries. So this is a kind of a nice way to keep yourself honest that you're actually getting the code that you want tested. And the way I always encourage people, doesn't always work out, what I encourage people to do is try and keep that at 100%. Not because you need to test everything, I don't think you have to test 100%, but instead what you can do is you can deliberately ignore something. So if you chose not to test something, you can make it clear to other people that you're intentionally ignoring it because, I don't know, maybe it's trivial, maybe it relies on a third-party library, who knows. So in this case, we want to make sure that the function is valid, is checked, but we don't really care if super valid is checked. And so we can add that ignore in there. So if we're running a report, it'll still tell us that as long as we have a test for the top one, it will still say we have 100% coverage. Yeah?
Will that ignore everything inside that function or just the function itself?
Just the function itself. The way it works is with that Istanbul ignore next, it'll ignore the next function, or the next branch, or the next whatever. It's super obnoxious to write if you're using arrow functions because you have to do something like this. Const super valid equals, and I think maybe, correct me if I'm wrong, Richard, something like this, Istanbul ignore next. You either that or you have to do it after the parameters. Anyway, it's really obnoxious and super ugly. So that sucks, but that's kind of the way it is. If you want to ignore a whole file, which there's a lot of cases that we would want to do that. Let me see if I can remember. I think I had one of these where I did that. There you go. You can say ignore the file. This is nice if you have a file that pretty much does like we use it for styles, we use style objects. And so we don't really care about testing style objects, who cares? So we'll just say ignore the file and it will ignore the whole thing. All right, so I went through a ton of stuff, but I wanted to make sure I got it in before time. So does anyone have any questions? Yes?
Could you show that the Lodash mock that you had done for the unique ID one?
Yep.
Cool.
All right, there you go. Yeah, almost, I will say, I almost always start doing this, like nearly 100% of the time I'll just export something hard-coded, and then nearly 100% of the time, 2 months later, I end up doing this. So if I was smarter, I would do this from the start, but I'm a slow learner.
Okay.
Anything else? Yes?
Could you give your thoughts on writing tests first or code first, test for development?
Test versus development, that's the best idea I've never been able to do myself. I don't know. I think it's super hard, especially with React. Yeah. I almost always do it on pure functions, just because whenever I'm writing a pure function, I have an idea of what I want, especially if you're doing like a lot of array parsing. But I almost never do it on components. I think it would be tough. Let's go far back and we'll work our way forward. Yeah.
So in a React functional component, a lot of times your methods rely on closures.
Uh-huh.
Have you found it best just to write a method in there where you pass in those parameters via closure, and then that calls your pure function with those values?
Yeah, that's, yeah. Let me see if I can make an example real fast. I have done that. Like if you wanted something like function, make object. as a non-click. Is that what you're talking about?
Yeah, so that way you can, so make object comes here and you're able to write test against that one versus the method inside of the
Yeah, that's what I do a lot. You'll want to make sure that you use callback or something, so it doesn't run it every time. But that's usually what I end up doing, just because it's then you get the advantage of having it outside, but also having it connected. Yep.
This is kind of on top, but because the KCDC has introduced no hooks, with hooks and Jest, does it kind of push you to not use classes anymore? Because then you'll more easily have a peer function. Or does it not really?
It doesn't care. I mean, if I ran this as, well, it's a class here. If I ran it as exports, defaults, right finder, use effect, render map, and then everything else, I'm pretty sure it worked the exact same. Oh, we're almost there. Why don't we just try it? I forgot the word function though.
use effects returning the function.
Oh, I need also use effect, yes. This is just easier for me to read. Right finder. Did not work. What did I do wrong? Oh, this is incorrect. This is incorrect. Use effect can only be assigned called inside the value of a function component. Looks like a functional component to me. Well, it doesn't really matter. The point is that, yes, it just doesn't care. Because, Just doesn't even care if you're using React. Just is closer to something like Jasmine or Mocha. It's a framework for running tests. And then stuff like React Test Library or Enzyme, that's the part where React actually gets hooked in. Yeah.
What's your experience with like DOM, checking the DOM and stuff in your Jest tests? What's that kind of been like? Is it pretty straightforward, or is there some maybe edge cases to know about?
So I used snapshots for a really long time, which kind of makes a rendering of the DOM. I would probably use those not so much anymore because I find, I don't know if anyone's used snapshots before, but let me just show you how they work. So let's get rid of my experiment that failed. And so a snapshot is it checks to make sure the output matches that. And then if you were to put another one in here, then the snapshot fails. What it does is it gives you the opportunity. So it says, well, this is what you wanted and this is what we have. The thing that's great about it, the thing that's horrible about it, is that you can push this button U, and it'll update that snapshot. The problem is that that's so easy that people are like, snapshot failed, hit U, and then walk away. And you'll look in the PRs, and they'll just be like, they'll be blank, they'll be just like nonsense. It's so easy that it actually makes it so it's no longer effective. So I would probably check for things that are important now rather than use snapshots, or use snapshots for as small a part as I could. All right, so as the runner of this meetup, I'm going to cut myself off because it's time to go. So if you have any other questions, talk to me. Otherwise, as usual, thanks for coming. Next time, I think we'll be at Vin Solutions. I can't remember, did Reggie confirm with you?
Not yet.
Okay, that's very likely.
Yeah.
So that will be coming up next time. So thank you.